So hey there, this is Kunal and welcome to yet another video in the series of socket programming. And till now we have learned almost everything about the TCP IP model, the theoretical aspect as well as the practical aspect. And we saw how to code socket programs and using the TCP IP model. Now if I just recap of what we have learned till now. So basically the TCP connection was established with the help of three-way handshake. And what I meant or what I mean by that statement is that it is a process of initiating a connection. Then once the connection is established, data transfer begins, and when the transmission process is finished, the connection is terminated by closing of an established virtual connection. And each of these three steps, like the creation, the transfer, and then closing, each of these three steps were done with the help of APIs which were there in the TCP IP model. So that was all about the TCP IP model, and now we would be looking at the other type of model. So basically there are two ways how you can connect the client to the server. First one was your TCP IP model and the other one is the UDP model. And now looking at the UDP model, we have that the UDP protocol works almost similar to TCP, but it throws all the error checking stuff out and all the back and forth communication. And so basically UDP assumes that error checking and correction is not important or performed in the application, and to avoid the overhead of such processing at the network interface level. So that was it. And going on to the next part, we have the TCP and its advantages and disadvantages. And as far as the understanding of the UDP model is concerned, now what I would be doing is I would be comparing the UDP model to TCP IP model, and then I think you would get an idea of what UDP is all about. So quickly reading over the advantages and disadvantages of TCP, that it helps you to establish or set up a connection between different types of computers. It operates independently of the operating system, and the TCP IP model has a highly scalable client structure architecture. The disadvantages of TCP are that it never concludes a transmission without all data in motion being explicitly asked. You can't use for broadcast or multicast transmission. TCP offers many features that you don't want. It may waste bandwidth, time, or effort. In this model, the transport layer does not guarantee delivery of packets, and replacing model in TCP IP is not easy. And now looking at UDP, we have under advantage that it never restricts you to a connection-based communication model. Broadcast and multicast transmission are also available with UDP, and data loss can be made. And disadvantages of UDP model are that in UDP protocol, a packet may not be delivered or delivered twice, and it may be delivered out of order, so you get no indication. The UDP mostly likely to suffer from worse packet loss. Now the question arises: you have this UDP model, you have this TCP IP model. Now, when to use what? Under such circumstances, we have that. So TCP is an ideal choice and it has associated overhead. Now, what do you mean by that? We will come to that later. And therefore, when most of the overhead is in the connection, your application stays connected for any length of time. Then UDP is ideal to use with multimedia like VoIP. Then we can use TCP sockets when both client and server independently send packets at that time, and occasional delay is acceptable. That is in the case of online poker. Then you should use the UDP if both client and server may separately send packets, and occasional delay is also not acceptable in the case of multiplayer game. And in order to conclude, we have the key differences between the TCP and the UDP model. So basically, the TCP was a communication protocol and using which the data is transmitted between systems over the network, right? And in this, the data is transmitted into the form of packets in the case of TCP, and it included error checking, it included the guarantee of delivery, and it preserves the order of transmission or the order of the data packets. Now, and as far as the UDP is concerned, the it was almost similar to the TCP protocol, and except that it doesn't guarantee the error checking and data recovery. And using this protocol, using the UDP protocol, the data can be sent continuously irrespective of the issues in the receiving end. And the second key difference between the TCP and UDP would be regarding the performance. And the TCP is slower and less efficient in performance as compared to UDP. Also, TCP is heavyweight as compared to UDP. On the other hand, the UDP is faster and more efficient than TCP. Then the last point is the reliability factor. The TCP is reliable as it guarantees delivery of data to the destination router. The delivery of data to the destination can't be guaranteed in UDP. So basically, the TCP provides error checking support and also guarantees delivery of data to the destination router, and this makes it more reliable as compared to the UDP model. While on the other hand, the UDP does not provide, or maybe it does only provide some basic error checking support using checksum. So the delivery of data to the destination cannot be guaranteed in UDP as compared to that in case of TCP. And one more point that I can make over here is that as far as the retransmission of data packets is concerned, the retransmission of data packets is possible in TCP in case the packet gets lost or you need to resend. That's why it's much more reliable as UDP. While the in case of UDP, the retransmission of packets is not possible. So that was it, and that was the end of the UDP theoretically. And in the next video, we would be seeing how you can code or how you can create a client server application using the UDP model. So till then, stay tuned.